Okay, so at least in my class, at least in 6th hour, there is a lot of confusion about dimensional analysis, so I'm going to explain a few problems, and hopefully that will help. This is number 1 on our worksheet. So if we're converting 31 grams to milligrams, we have our 31 grams, and we're going to put that over 1. And then we're going to multiply that. In our explanation they had this as a table, but it's just a mathematical equation, so you can set it up either way. So we're going to multiply that. We want to get rid of the grams, so we're going to put grams on the bottom, and we want to go to milligrams. Since grams is our base unit, we could add a step in here and have grams over grams, as it said in the video, but we don't really need to do that because grams already is our base unit. So our grams are going to cancel out, and that's what we want. We want to just be left with milligrams. Now we're going to put a 1 with our prefix, and then we're going to come over here and look at our table that we filled out, and we're going to see that milligrams was 10 to the negative third. So we can put 10 to the negative third down here. And now you just multiply across. So you're going to have 31 milligrams, and that's going to be over 10 to the negative third. Now, if you remember in math, you can move something up to the top as long as you change the sign on its exponent. So we can really just move the 10 to the negative third up to the top and just make it 10 to the positive third. So we're going to have 31 milligrams times 10 to the positive third. But that's not correct scientific notation, so we need to move the decimal over and have 3.1, and since it's left larger, because it's LL, left larger, then we know that we're going to be increasing our decimal by 1, or not our decimal, our exponent, because we moved the decimal over 1. So it's going to be 10 to the 4th. And that's our answer. So on number 3, we have 8.4 times 10 to the negative 6th kilograms. To get rid of the kilograms, we're going to put that on the bottom so that they'll cancel out. And we have to go pay respect to our base unit, which is grams. So we're going to put the 1 with our prefix, and then we're going to come over to our table, see that kilograms is 10 to the third. But we don't want to end up with just grams. We want to go all the way to centigrams. So we want to cancel out the grams and move on to centigrams. We're going to put 1 with our prefix, come back to our table, see that centigrams is 10 to the negative second, and then we can multiply through. Our kilograms cancel, our grams cancel, so we'll have 8.4 times 10 to the negative second times 10 to the third over 10 to the negative second. So we can move our 10 to the negative second to the top as long as we make our exponent positive in this case. So then if we have all of these exponents, we can just add them. So we'll end up with 8.4 times 10 to the negative 1. And since that decimal is in the right place, we don't have to change it, and we are done. So I'm going to skip down to number 12 because the rest of those are pretty much like 1 and 3, so hopefully you'll be able to figure that one out. The last few are a little bit different, and we're finding the volume. So a rectangular solid measures 1 meter by 5.6 centimeters by 2.1 decimeters. It expresses its volume in cubic centimeters. Convert one dimension at a time. So we have 1 meter by 5.6 centimeters by 2.1 decimeters. So we need to convert all of these to centimeters so that we can find the volume of this object. So 1 meter, 1.0 meters. Since meters is our base unit, we don't need to change it into our base unit. We can just go ahead and make it cancel into centimeters. We're going to put our 1 with our prefix, come to our table, and see that centimeters is 10 to the negative second. And then just multiply across. So we'd have 1.0, 10 to the negative second would move up to the top, giving us 10 to the positive second as our answer. So there's one of our units. 5.6 centimeters is obviously already in centimeters, so we need to do 2.1 decimeters. Since this isn't our base unit, we do need to convert it into our base unit. So we're going to put our 1 with our prefix, come to our table, see that decimeters is 10 to the negative first. And now we can multiply to get rid of the meters and change it into centimeters. Put our 1 with our prefix, see that centimeters is 10 to the negative second. And now we can multiply across. This is going to move up to the top and change signs, so we'll get 10 to the second. And then we can just add our exponents. Or in this case, subtract 2 minus 1 is just going to give us a 1. And that is centimeters. So then we have, now we want to find the volume. And to find the volume, we just multiply because it's a rectangular solid. So we'll have 1.0 times 10 to the second times 2.1 times 10 to the first times 5.6. Now if we watch the video on scientific notation, you learned that if a number is in scientific notation, you can just perform the calculation with the significand and add the exponents. So our significants are 1.0 and 2.1 and 5.6. But here on the 5.6 we don't have an exponent because it isn't in scientific notation. So we need to put that in scientific notation. Now, multiplying by 10 to the 0, 10 to the 0 is just 1. So we're not changing this number at all, we're just adding that so that we'll have an exponent to add whenever we're multiplying in scientific notation. So we multiply our significance, 1.0 times 2.1 times 5.6, and we're going to get 11.76. And then we're going to add our exponents. So we're going to have times 10 times 2 plus 1 plus 0 times 10 to the third. But our decimal isn't in the right place since we're moving it to the left, and the left increases our exponent because it's left larger. We're going to have 1.176 times 10 to the fourth centimeters cubed.